Okay, good afternoon, class. So at this point we are wrapping up our trigonometry chapter. You have indicated, I think, already which topics, or sorry, not which topics, but which questions was an issue. Not so? Okay. Just get it quickly. There we go. Revision test topic 5. This is the revision exercise on page 109. So the questions that you have indicated, that once you have marked it, these were the issues. Okay. So for the next 40 minutes, we're going to try and sort out most of your issues here. Okay. Since you're people that doesn't talk much to me, you just stop me if you don't understand whatever. Okay. I'm not going to ask you every time, where did you go wrong? And then everybody looks down again. Then I carry on and ask you again, and then you look down again. Okay, so I'm sure I'm not going to get through all these questions, but let's get through most of them as much as the time permits. Okay, so as we're standing here at number 3, we are told if sine of a is equal to 12 over 30 and a is obtuse. If it's obtuse, that means to say it's an angle between 90 and 180. Which means to say that the angle is in the second quadrant. So what we do is we draw this here. Okay, so we say, okay, we got your angle A here. Sine stands for opposite over adjacent, over hypotenuse. So it's 12, 13. Apply Pythagoras, I should get minus 5. Okay. Why negative? So it's negative part of your x-axis. Then we are told that tan of beta, where beta is greater than 90, is equal to 4 over 3. So let's say, okay, tan is positive. In which quadrants is tan positive? All stages to Clement is 1 and 3. But beta is greater than 90, so it's 2, 3, 4. So it has to be in quadrant 4. So we draw the beta angle there. In quadrant 3. There's your beta. So what does tan stand for? Opposite, there's your reference, opposite over adjacent. I say, hang on, but that is on the negative part of your y-axis and the negative part of your x-axis. So both is negative. So negative divided by negative is positive, which results in tan being positive in the third quadrant. Can you see that? Then we need to calculate the hypotenuse. How do you calculate the hypotenuse? Pythagoras. So negative 3 squared plus negative 4 squared is equal to r squared, which give you 25 and 5. The root of 25 is 5. The hypotenuse will never be negative. Okay. So determine the ratios without using a calculator, calculating the values of. In the first case, you got sine of a, now number 1, a minus b. So a minus b is the sine expansion must be applied here. So it's going to be sine a cos b minus sine b cos a. So as you can see here, is your angle A, the opposite is 12 over your hypotenuse is 13 times cos of B is adjacent, which is negative 3 over 5. Now you see, now I use this triangle. Okay, minus sine of B is negative 4 over 5 cos of A. Again with the first triangle, cos is adjacent, which is negative 5 over 30. So that would simply give us, what did this give us? Negative 56 over 60. Okay. So what I'm going to do is I'm going to take this off here, because as you can see, the space doesn't permit us to leave it on the board. Cos of a minus b, cos expansion. We can't apply this straight from the diagram, because we have cos of, we got angle A and we got an angle triangle B here. Can you see that, people? That's why I can't use a minus b. So it's going to be cos of A, cos of B, plus sine of A, sine of B. When it says an angle A, we can only use the first diagram. This is angle B, we can only use the second diagram. So cos of A, cos is adjacent, which is negative 5 over 13. Adjacent of hypotenuse, cos of B is negative 3 over 5. Plus cos of A, negative 5 over 13. Nope. Sine of A is 12 over 13 times sine of B is negative 4 over. That gives us an angle of a ratio of negative 5 divided by 13 multiplied by negative 3 divided by 5 plus 12 divided by 13 times negative 4 divided by 5. That gives us 27 over 65. Is that correct? Huh? No. What should the answer have been? Here's one mistake. Is that 12 over 13 multiplied by negative 4 over 5. Negative 33 over 65. Thank you. Then the next question says, so that is negative 33 over 65. So the next question says, you must get the ratio of tan of A minus B. Now we didn't delve into the tan expansion. Not so. However, we know that tan is the same as sine over cos. So in other words, tan of A minus B is the same as sine of A minus B over cos of A minus B. Okay. So sine of A minus B is negative 56 over 65. That means divided by cos of A minus B is negative 33 over 65. Which is now negative 56 over 65 times 65 over negative 33. That cancels. Leaves you with, and 3 going to 56. No. So it's just simply going to be 56 over. Okay. Any confusion here? Again, look down. Okay, and the next question says, using compound angle formulae to prove that. So of course, left hand and right hand side story. So let's go with 4.3 first. So I'm going with the sine expansion immediately. So the left hand side is equal to sine of 30 cos of x plus cos of 30 sine of x plus cos sine cos 30 cos x plus sine 30 sine x. Okay, so that takes us to the special 30-degree triangle there. 1, 2, root 3. Sine of 30, of course, so half cos x plus cos of 30 is root 3 over 2x cos sine x plus cos of 30 is root 3 over 2 cos x plus a half sine x. If we look at what you have on the right hand side, okay, we have in the bracket sine x plus cos x. Okay, one of two things could happen. I can either multiply the right hand side out and make it the same as the left hand side as it stands here, or I can add like terms. And we put the what a half plus root 3 over 2 is, the denominators are the same, can be written as 1 plus the square root of 3 over 2 cos x and you do the same for sine, you're also going to get 1 plus root 3 over 2 sine x. So what do we notice now? Is that 1 plus root 3 all over 2 is a common factor, which we will be taking out. So 1 plus root 3 over 2. We take it out, I'm left with cos x plus sine x, which is also equal to the right hand side. Okay. Okay. Then if you look at the next one, in 4.4, again the left hand side is more complex. So it will be easier to expand than to reduce. Okay. So as you can see here, we're going to go with the sine expansion. So it's going to be sine of A cos of B plus sine of B cos of A times, and that stand for multiplication there, with this written next to each other, sine of A cos of B minus sine of B cos of A. Okay. As you can see, it's the conjugate pair there. I'll multiply the first and the last, which now gives us sine squared A cos squared B minus sine squared B cos squared A. Now if I look at the right hand side, I only have sines. So what I do is I retain the sines and change the coses. Do something dealing with sine. So I go sine squared. Cos squared of B can be written as what? 1 minus sine squared B minus sine squared B can be written as 1 minus, so cos squared B can be written as 1 minus sine squared A, sorry. So what do I do now is get rid of the bracket. As you can see, this is sines only now, so that would simply be sine squared A minus sine squared A sine squared B minus sine squared B plus sine squared B sine squared A. What you should note at this point is that we have like terms. Not so. So what is negative sine squared B sine squared A plus sine squared B sine squared A? Cancel. Not so. So we are left with in turn sine squared A minus sine squared, which is then equal to the right hand side. Okay. Let's look at number 5. In number 5, it says convert these expressions to one trigonometric ratio and you evaluate if possible. So what we do always is to change our angles all to acute angles. Okay. So sine 150 can be written as sine of 180 minus 30, cos of 30 plus reduce, that's going to be cos of 180 minus 30 times sine of 360 minus 30. Where that is now equal to, in the second quadrant, sine is positive. Sine 30 cos 30 plus, in the second quadrant, cos is negative. It's going to change this positive to a negative. So it's negative cos 30 times. Now 360 minus, that's again in the fourth quadrant. Is sine positive or negative? Negative. But you're going to change that again to a positive. Sine 30. So if alpha is 30 and beta is 30, then this would be alpha and beta. So that takes us to sine alpha cos beta plus cos alpha sine beta. It's going to be the sine expansion, not so. So it's going to be the same sine or opposite sine? Opposite sine, same sine, since we're busy with sine. So So it's going to be sine alpha plus beta, which is the same as sine of 60, which is then the root of 3 over 2. Okay, coming from that triangle. Looking at the next one. Again, people, I'm going to try and get it in the same angle. Okay, as we can see, that sine of 15 and 75 are co-functions or co-ratios. Okay. So what I do is I always keep my first and change the second. So it will be cos squared 15 minus 75 can be written as what? 90 minus. So it's going to become cos squared 90 minus 15. Not so. The 90 minus 15 takes into the first quadrant. Cos is positive, but cos changes to sine. And there we go. We got cos squared 15 or cos squared alpha minus sine squared alpha. That should remind us of cos 2 alpha, the double angle. So it will simply be cos 2 times, and what's the angle in this case? 15. What is 2 times 15? 30 degrees. So we go 30, so it's 1, 2, root 3. What is cos of 30? Root 3 over 2. Okay. So this is a common asked question. I've seen this question coming up already in the past exam or past grade 12 paper as well. No? Okay, the next one we got cos of 10, that's already acute. We first change everything to an acute angles. Okay, so we got cos 10, that can be written as cos 360 minus 20 minus, that's going to be in the third quadrant, so it's 180 plus 10. Again, we try and you make that angle in terms of 10 or in terms of 20, and we do the same to 200. Why? So that we can use the compound angle identity. Okay. That gives us, for sine 200, is going to be sine of 180 minus 2. Okay. Why am I not going with 90 and 270? Because here I can see already it's cos, cos, sine, sine. If it was cos, cos, sine, cos, then I would make an effort to change it. Yes? Should be plus. Yes? Same problem. Okay, nice. You guys can see my problems already? Nice. So the next one is already in its order. So that is fine. So it's sine, sine. But it's supposed to have written sine, cos. Not so. So I'm going to change that one to a cos. So it's going to be sine 10 times sine. I can either write cos 20 or first write the angle in there. It's going to become cos 90 minus 20, which is 70, plus we got the sine. We need a 10 degree, so it's going to be 90 plus 10. You see, otherwise that's going to give you 180 minus 80. It's also 100. But here's no 80 degrees here on the side of the plus sign. Can you see that? That is why I'm drawing in the 10. Why? So that I can use the compound angle thing. So it's times sine of 20. So using a reduction formula, that's going to become cos of 10 times cos of 20. That's going to give you in the third quadrant, sine is negative, change the negative to a positive. Sine 10 times, this is also in the third quadrant. The sine is negative in the third quadrant, making that the negative sine of 20. That's all over. Sine of 10 remains sine of 10, 90 minus first quadrant, cos is positive, changes to sine there, sine 20. 90 plus second quadrant, sine is positive, so it's positive cos 10 times sine 20. So we got cos, cos, sine, sine. Which rule? Cos. Cos, cos, sine, sine. Which rule? I made another mistake. Where? This one here? There was 90 minus. This was. Oh, so this is sine here. Sorry, that's my mistake. Not here. So now that changes to cos. My mistake here. So sine, cos, cos, sine. Nice. So that's simply going to give us cos function, or the cos double angle. So that would be what? 10 plus 20 over sine 10 plus, okay, sine is the sine, the sine stays the same. So it's going to become cos of 30 over sine of 30. Again, that takes us to the special triangle then. So it's 1, 2, root 3. So cos of 30 is root 3 over 2. Must be divided by sine of 30, which is 1 over 2. Give you an answer of root 3 over 1, which is root 3. Okay. Number 6. Right, question 6, it says show that definitely left hand side is more complex. So what I do is I take 40. 40 can be written in terms of an angle of 20. Not so, it can be written as a double angle there, so it's going to be sine 2 squared 20 plus sine of 40 can be written as sine squared of 2 times 20 plus, now this here I'm going to also try and write it in terms of 20. It can be written as sine squared 60 plus 20. Okay, so that is simply sine squared 20 plus, this here can be written as a sine 20 cos 20, not so, and a 2 in front of it. That is now cos, sorry, not cos but sine. 2 alpha can be written as 2 sine alpha cos alpha. Now the alpha angle here is now 2 in. Can you see that? You all okay with it? Yeah? But you see there's a square on top there, so I must put that in the bracket, square plus, now here's a double angle expansion there that needs to take place, a compound angle, sorry. So it will be plus, how did you got the plus there? Sine 60 cos 20 plus cos 60 sine 20. And that also has to be squared because of that square. Okay, so it's going to be an expansion taking place here. So that's going to be sine 20 squared plus 4 sine squared 20 cos squared 20 plus, now sine of 60 is going to be root 3 over 2. Cos of 60 is half. Okay, I'm doing that because I don't want to rewrite anything again. So the first term squared is going to be 3 over 4 cos squared 20 plus first term times second term times 2. So that is going to give you the root of 3 over 4 cos 20 sine 20 okay, I think I'm going wrong somewhere now. It's cos 20 sine 20 plus a quarter sine squared 20. Okay. Oh, okay, I see now. Then Add like terms. Sine squared 20. So you like term to sine squared 20. Yes, right at the end. So I'm just going to sketch out there's a lot of terms here. So that's going to give you 5 over 4 sine squared 20. Okay. There's no like term to 4 sine squared 20 cos squared 20. So what I'm going to do is I'm going to replace that with something dealing with sine. So it's going to become plus 4 into 4 sine squared 20 into what? 1 minus sine squared 20. Okay? The cos squared. Okay, so what I'm going to do is I'm going to replace this cos squared also with 1 minus sine squared. Okay, then the like terms can add, so make it a bit easier for us. So it's 1 minus sine squared 20. Okay, plus the root of 3 over 4 cos 20 sine 20. Okay, so what I'm going to do now is I'm going to get rid of the brackets. Let's pull this down here. So I'm going to get rid of the brackets now by multiplying in. So it's 5 over 4 sine squared 20 plus 4 sine squared 20 minus 4 sine 420 plus 3 over 4 minus 3 over 4 sine squared 20 plus, now what you should notice here, that I can see this is going to be a 2 sine alpha cos alpha coming from it. Can you see that? Okay, so if I put a 2 in front of this, okay, then I must divide by 2, is going to give me 8 here. Okay, so it's going to be root 3 over 8. Now I'm going to get the 40 again. I went somewhere wrong. Just put it down again. Just take this out here. Start over. I think I'm messing up somewhere here. Check again now where I messed up. And so I'm not erasing yet. $60.40. Let's try this. We got sine 80 or 60 to 20. Any of you get this right? Sorry? No. Let's sine 20 1860. Which topic is this? This topic 5. The revision exercise. The exercise, yeah. This is number 6.4. Alright. Thanks, boss. Right. So what we should have done was, I went with a double angle and I got this lost thing. So what I needed to have done was to say sine squared 60 minus 2 plus sine squared 60 plus 2. In that case, the one will cancel the other. Okay, you'll see now, which is the left hand side there. So my mistake was writing that as a double angle. I could have gone away with it. Okay. So it's going to give me sine squared 20 plus the sine expansion here. It's going to be sine 60 cos 20. Same sign minus sine 20 cos 60. And it must be squared plus that would be sine 60 cos 20 plus sine 20 cos 60. Alright, so that's simply going to give us sine squared 20 plus. Now this here is going to be root 3 over 2. 1 over 2 root 3 over 2. That's 1 over 2. Okay, so square the first term is going to be 3 over 4 cos squared 20 minus that times 2 is going to be half times 3 over 4 is root 3 over 4 times 2 is root 3 over 2 cos 20 sine 2 plus the last term squared is going to give you a quarter sine squared 20, and this is plus first term squared is going to give you 3 over 4 cos squared 20 plus that times 2, so going to give you root 3 over 2 cos 20 sine 20. Last term squared is going to be a quarter sine squared 20. So that gives us, that cancels. That's what I needed. Otherwise I was always going to be stuck there. So sine 20 plus a quarter sine 20 plus a quarter sine 20. And these are like this. There are 3 of them, which are going to give you 3 over 2 sine squared 20 plus, now root 3 over 4, no, 3 over 4 cos squared 20 plus 3 over 4 cos 20 is going to be 3 over 2 cos squared 20. So as you can see, 3 over 2 is a common factor. I'm left with sine squared 20 plus cos squared 20. And sine squared x plus cos squared x is 1. Sine squared 20 plus cos squared 20 is 1. It's simply going to be 3 over 2 times 1, which is 3 over 2, which is equal to the right hand side. A very good sum. Nice. I like it. Okay, would have made me lost at least 4 marks if I had stopped in the exam. So I would have only gotten that mark and the expansion mark. That's it. Okay. They're not going to give me a mark for sine 2 times 20 because that didn't take me to the answer. There's no way I could have gotten the answer. That is, although it's right, You can't get a positive mark, so you're not going to land up where you needed to. Okay. That's it. Very good summary. Got me making a mistake as well. But at least now I can put it in your exam. Because now you know how to do it. Not so? Yeah, I'm again talking to myself. No problem, people. Question 7.1. Prove that sine 45 plus x times sine 40. Again, left hand side more complex. So we go left hand side is going to be the sine expansion. It's going to be sine 45 cos x. Same sign. Sine 45. Cos 45 sine x. Okay? And it must be multiplied by sine 45 cos x minus cos 45 sine x. Okay, so again, this can be written as 1 over root 2, that's the 45-degree triangle there. So it's 1 over root 2. So it's root 2 cos x plus root 1 over root 2 sine x. 1 over root 2 cos x minus 1 over root 2 sine x. Again, what you should note is the conjugate pairing form there. Multiply the first and the last. 1 over root 2 times 1 over root 2 is 1 over 2 cos x squared minus 1 over 2 sine squared x. Okay. So as you can see here, we got 1 over 2 as a common factor there, which now gives us cos squared x minus sine squared x. Now what does cos squared x minus sine squared x mean? It will be cos 2x. So it's half cos 2x, which is indeed equal to the right hand side. Now there's a hence part of this question. It says hence determine the value of sine 75 sine 15. Now what you should note is that there should remind us something about that. Not so. If you say 45 plus a number is equal to 75. 45 plus what is 75? Sorry? 30. So what we should note here is that sine 75 sine 15 could be written as sine 45 plus 30, not so, times sine 45 minus. Can you see that, people? So we managed to prove that sine 45 plus x times sine 45 minus x is equal to a half cos 2x. But what is on x's place here? What is on x's place? Huh? 30. So what I'm going to do is I'm going to replace that x with a 30. Does it make sense? Because now I got this here looking exactly like that there. Not so, but that we have proven that the left hand side is equal to the right hand side. You make the leap. So x is what? 30. What is 2 times 30? 60. What's cos of 60? Cos of 60 is half, which is 1 over 4. Okay, you can't help but just to love trig, no? It's very, very exciting. Okay. Right, next 7.2. In 7.2 again, you must prove that the left hand side equals the right hand side. Cos 45 is 1 over root 2. So if I can prove that sine 105 plus cos 105 is 1 over root 2, the job is also done. Okay. So the left hand side, that is simply going to be sine special angles. 60 and 45. Not so. 60 plus 45 plus cos 60 plus 45. So that's simply going to give us sine expansion, sine 60, cos 45, same sign, sine 45, cos 60, plus cos 60, cos 45, minus sine 60, sine 45. So that is 45, so it's 1 root 2. So it's 30, is 1 2 root 3. Okay? Sine of 60 is root 3 over 2 times 1 over root 2 plus 1 over root 2. Cos of 60 is 1 over 2 plus cos of 60 is a half times 1 over root 2 minus cos of 60 is root 3 over 2 times 1 over root 2. So I'm looking to cancel somewhere. That yes, definitely cancels. So that is 1 over 2 root 2 plus 1 over 2 root 2 is simply going to be 2 over 2 root 2, which is 1 over root 2 or root 2 over 2. Okay? Then we got the right hand side. We got the right hand side. It's going to be cos of 45, which is 1 over root 2, which is equal to the left hand side. Okay? Number 8. We are asked to prove the following identity. In 8.3 you asked me to do. Right, so what do we have here? Double angle. So left hand side equals sine x plus 2 sine x cos x over something. But if you look at the numerator, you're going to see that sine is a common factor. Then I'm left with 1 plus 2 cos x. So somehow or other, I'm going to have a trinomial at the bottom and factor. Okay. If you look at the denominator here, the cos of 2x can be 1 of 3. Which one am I going to use? The one dealing with sine. Why? Because the middle term is a sine. So it can go into trinomial factorization. Okay. So in the denominator here, it's simply going to be 1 plus sine x minus 1 minus 2 sine squared x. Okay, not going to go into trinomial, going to go into a common factor factorization. Actually easier. So it's 1 plus sine x minus 1 minus plus, why did you say 2 sine squared x. No, it is trinomial. No, it's not. So that's going to give us sine x into 1 plus 2 cos x over sine x is a common factor. Then I'm left with 1 plus 2 sine x. Where the sines cancels leaves you 1 plus 2 cos x over 1 plus 2 sine x, which is equal to the right hand side. Okay. Point 4. In 8.4, again left hand side, I'm going to change 6 I'm going to change 6 to the double angle. So that it can be written as cos of 2 times 3. I'm going to use the one dealing with cos squared alpha minus sine squared alpha. So cos squared 30 minus cos squared 30, 3x sorry, minus sine squared 3x, which now gives you cos squared 3x minus cos squared 3x plus sine squared 3x. That cancels, leaves you with sine squared x, which is equal to the right hand side. As I told you initially, we are never going to get through all this work here, but this marks the end of this chapter. Okay? During tomorrow's lesson, there's quite a few sums that you still need explanation on. But I'll send you the memo of this to the group, okay? And if there's still issues pertaining these sums, just bring it to Friday's lesson. So during tomorrow's lesson, you can just put your assignments on the table. We're going to look at, just collect it please, ma'am. We're going to look at analytical geometry, the last part thereof, okay? People enjoy the rest of your day. Good morning class. Good afternoon class. And I'm sorry you don't have homework today, okay?